Eliminate the potential for fault masking on your machines. With the new safety standard EN ISO 14119, the problem of fault masking has gained particular importance. In this video, we will show you what fault masking is and how you can resolve this potentially dangerous situation with sensor solutions from SICK. Fault masking can occur in a series connection of switches with volt-free contacts, independent of their manufacturer. These include non-contact magnetic safety switches, electromechanical safety switches, and safety locking devices. To see how fault masking occurs, let's have a closer look at a packaging machine. The hazardous part of this machine is secured with 6 doors. Each door is being monitored by a magnetic safety switch. Opening a door breaks the contacts of the associated safety switch and interrupts the current flow. The safety controller stops the machine, protecting the person from injury. Closing the door closes the contacts, restoring the current flow and enabling the machine restart. But what if some external impact damages the cable of the second safety switch and causes a short circuit on one of the channels? When the doors are closed, the short circuit remains undetected and the machine runs as usual. Opening the second door opens the contacts of the second safety switch. Because of the short circuit on channel 2, the current flow is interrupted only on channel 1. The safety controller detects the signal change and switches the machine off. But because the signal change was detected on only one channel, the safety controller evaluates this as a sequence fault and will not allow the machine restart. Trying to find the cause of the error, the operator opens and closes different doors, each time trying to restart the machine to check if the problem is eliminated. Opening the first door breaks the signal on both channels, as the signal is interrupted before the short circuit. When the door is closed, the input requirements of the safety controller are satisfied, as there is no longer a sequence fault. The machine can now be restarted. The fault at the second safety switch is now masked. Despite the short circuit on one channel, the machine could be started again, as the safety controller does not see this fault anymore. As the first fault was masked, the second fault on the same safety switch can be fatal. As the cable was already damaged before, the second fault is even more probable. The second fault would lead to the loss of the second channel and therefore to the loss of safety function. The machine will then keep on running even if the door is opened. Because of this possible danger, the standard for interlocking devices and the forthcoming technical report limit the performance level of cascaded safety switches with volt-free contacts. To avoid this limitation, SICK offers several solutions. First, the switches with monitored semiconductor outputs, and second, the innovative safe sensor cascade FlexiLoop. Test pulses of OSSD outputs enable the safety switch to constantly monitor the channels for failures. In case of a short circuit, both outputs will be switched off, stopping the machine. This failure detection allows the achievement of the highest performance level, even in the cascade. As we have just seen, the series connection of safety switches can be performed for switches with volt-free contacts, but with the risk of fault masking and possible reduction in performance level. Series connection can also be realized for switches with OSSD outputs without the risk of fault masking, but it will be limited only to specific cascadable OSSD sensor types. But what if you need the highest level of safety and the possibility to use different sensors in the cascade independent of their outputs? The right answer is FlexiLoop. FlexiLoop allows the connection of different safety sensors in a series without the reduction in the performance level and offers detailed diagnostic information for each safety device. FlexiLoop monitors the wiring to each sensor and in between the FlexiLoop nodes and detects every possible fault instantaneously. Fault masking is not an issue with sensor solutions from SICK.